Have you ever wondered what's inside the moon? That's a question that has sparked human curiosity for centuries. And it was in the summer of 1969 that we finally began to unravel the mysteries of our closest celestial neighbor. The Apollo 11 mission, led by NASA, the American Space Agency, was a benchmark in human history. Astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins embarked on a journey of more than 200,000 miles. A journey that would culminate in Armstrong's iconic first step on the lunar surface. This was a moment that not only marked a victory in the space race, but also ignited a worldwide interest in the moon and its secrets. The moon landing was more than a mere touchdown on an alien world, it was an embodiment of human ingenuity, courage, and curiosity. As Armstrong's boot made contact with the lunar dust, he uttered the legendary phrase, "That's one small step for man, one giant leap for mankind." And indeed, it was a leap into a new era of exploration and discovery. The lunar samples brought back by the Apollo missions were instrumental in our understanding of the moon. The rocks and soil, worn by billions of years of cosmic radiation and meteorite impacts, told tales of the moon's history. These samples triggered a wave of lunar research that has continued to this day. Scientists have used these precious materials to study the moon's composition, its origin, and its relationship with our planet, Earth. The moon, our friendly neighbor in the night sky, is more than a mere satellite. It's a time capsule, holding secrets of the early solar system. It's a laboratory for studying planetary evolution. And perhaps most importantly, it's a stepping stone for future exploration of the cosmos. With the moon landing, mankind took a giant leap forward in space exploration, opening the door to decades of lunar research. The journey to understand what's inside the moon began with that one small step, and the quest continues, as we strive to unlock the mysteries of our universe. So what did we find when we first peered beneath the moon's surface? When the Apollo missions triumphantly returned to Earth, they did not come back empty-handed. They brought with them a treasure trove of moon rocks, rocks that would give scientists their first real clues about the composition of the moon's crust. These rocks, some as old as 4.5 billion years, were like time capsules from the moon's past. They told a story of a fiery birth, of a young moon covered in a sea of molten rock. As this lunar magma ocean cooled and solidified, it formed the moon's crust, a layer of rock up to 40 miles thick in some places. And what an unusual crust it is. Unlike Earth's crust, which is made up of a variety of rock types, the moon's crust is primarily composed of just one type of rock, known as basalt. This basalt is rich in a mineral called plagioclase feldspar, which gives the moon its characteristic gray color. But these rocks held an even bigger surprise. They contain tiny amounts of a rare isotope called helium-3, a potential source of clean nuclear fusion energy. With enough helium-3, we could potentially power the Earth for thousands of years. And where is this precious resource most abundant? You guessed it, the moon. However, these rocks also raised new questions. They were remarkably dry, lacking the water-bearing minerals found in Earth rocks. This was puzzling because, according to the leading theory, the moon was born from a giant impact with Earth, which should have left it with a similar composition, including water. These lunar rocks, as mundane as they might seem, were the first pieces in the puzzle of understanding what's inside the moon. They continue to be studied and restudied, each time yielding new insights about our closest celestial neighbor. And yet, for all we've learned, the moon still holds many secrets, waiting to be discovered. These lunar rocks, as mundane as they might seem, were the first pieces in the puzzle of understanding what's inside the moon. But the moon's crust is just the beginning. What about its core? The answer to that question takes us on an adventure deep beneath the moon's surface into its enigmatic interior. The moon's interior is a layered structure, much like that of our own planet, Earth. The outermost layer, the crust, gives way to the moon's mantle, a thick rocky layer that extends to great depths below the surface. This mantle, composed primarily of minerals like olivine and pyroxene, is not a uniform layer. It has been shaped and molded by billions of years of geological activity. And it's here where we find the remnants of moonquakes. Moonquakes, you ask? Yes, indeed. These are the lunar equivalent of earthquakes, vibrations that ripple through the moon's interior. These are not just fascinating natural phenomena, they are also invaluable tools for scientists seeking to understand the moon's inner structure. Here's where things get really interesting. When a moonquake occurs, the seismic waves it produces travel through the moon's interior. By studying these waves, scientists can glean vital information about what lies beneath the moon's surface. It's akin to using a giant X-ray machine to peer into the moon's geological bones. The data gathered from these moonquakes has led scientists to theorize that beneath the mantle lies the moon's core. Unlike Earth's core, which is primarily composed of iron, the moon's core is believed to be small and composed of sulfur and nickel, encased in a shell of partially molten rock. This core, although small, plays a crucial role in the moon's magnetic field. But there's still so much we don't know about the moon's core. Its exact size, composition, and temperature remain topics of heated debate among scientists. Yet, with every moonquake and every piece of new data, we inch closer to the answers. With every moonquake, we get another glimpse into the moon's core, revealing its hidden secrets bit by bit. From the outer crust to the deepest reaches of the core, the moon continues to captivate and intrigue us with its mysteries. You might be surprised to learn that the moon's core is not what we expected. For a long time we held on to theories, visualized diagrams, and even made educated guesses. But recent research has thrown a wrench into our previous understanding, unveiling a core that is both intriguing and baffling. The moon's core, unlike Earth's, is small, making up merely 2 to 4% of its mass. This is a stark contrast to our planet's core, which accounts for about 1/3 of its mass. The difference is striking, and it challenges our previous assumptions about how celestial bodies, including our own moon, are structured. Now let's delve into the composition of this mysterious core. It's primarily made up of iron, but there's a twist. It also contains a substantial amount of sulfur, an element not typically associated with cores of terrestrial bodies. This abundance of sulfur reduces the core's density and prevents it from completely solidifying, a phenomenon starkly different from what we see in Earth's core. One of the most surprising aspects of the moon's core is its magnetic field, or rather, its lack thereof. Earth's core generates a strong magnetic field that shields us from solar radiation, but the moon's core doesn't. This absence of a magnetic field has puzzled scientists and opened up a whole new realm of lunar mysteries to explore. But why do these findings matter? Well, they challenge our previous understanding of the moon and other celestial bodies. They reveal a complexity in the moon's structure that we hadn't anticipated, making us rethink how we approach future lunar explorations. Moreover, these discoveries are not just about the moon. They also provide valuable insights into the broader universe. By understanding the moon's unique core, we gain a better understanding of how planets and moons form and evolve over time, giving us a glimpse into the cosmic dance that has been unfolding for billions of years. These latest findings have turned our understanding of the moon's core on its head, showing us that there's still so much to learn. So, what's next in our quest to uncover the moon's secrets? Well, the journey is far from over. As we delve deeper into the realm of lunar exploration, we are constantly planning new missions and setting ambitious goals. Among these is the Artemis program, an initiative by NASA, aiming to land the first woman and the next man on the moon by 2024. This isn't simply about making footprints on lunar soil, it's about establishing sustainable exploration by the end of the decade. Beyond the Artemis program, other nations are also setting their sights on our celestial neighbor. China's Chang'e program has already landed rovers on the moon, and has plans for manned missions in the future. Similarly, India's Chandrayaan program is also making strides in lunar exploration. But what do we hope to achieve with these missions? What are the scientists so eager to discover? The answer lies in the moon's potential. It's not just about understanding the moon better, but also about how this knowledge can benefit us. For instance, learning about the moon's geology can provide clues about Earth's early history. Furthermore, the moon could serve as a stepping stone for further space exploration. By establishing a lunar base, we could use the moon as a launchpad for missions to Mars and beyond. This would significantly reduce the energy required for such missions, making them more feasible. Moreover, the moon's surface is rich in resources like helium-3, a potential source of safe nuclear energy, and water ice, which could be converted into rocket fuel. The exploitation of these resources could revolutionize space travel and energy production on Earth. As we continue to explore the moon, who knows what other surprises await us? One thing is certain, the moon still has many secrets to reveal. So, let's keep our eyes on the sky and continue to push the boundaries of our knowledge and capabilities. The future of lunar exploration looks bright, and we can't wait to see what's next.